This is the README file of the project. Here you can see the folder structure to navigate in the directory, and the project overview is given in the PDF file. These are the commands to install the packages in the Conda environment and then activate the Conda environment. And these steps are to run the Docker container that runs the Fast API application, which is used to fetch the information about the materials. And this command is to run the application itself. I will now go to my terminal and run this application. Here you can see the graph, and which the agent has created to me, and then it is asking for the job type, and then it will ask for the quantity, and then it will ask for the currency, as I can see in this visualization. And when it's asking for the currency, it is also running another job in the background. That it is calling the API, and it is to fetch the information about the material, quantity of the material. And when it's asking for the VAT, it is running the database query. And after I enter information about the VAT, it will then perform the pricing, and it will also be asking for the customer. So here, this is the workflow, and it is quite efficient. It's running in parallel. This is the design flow. Let me enter the information and see how it works. So cupcake is not a valid. Cupcakes is the valid job type. I'll put -2, let's say -1. It's not a valid input. I'll put 2 here, and GBP is the default currency, so I'll just press enter, and 20 is the default, but I'll just put 2 here, or let me put -1. It's not a valid input, so let me put 2 as VAT, and the customer name, I'll say ADN, and 20, I'll put 2024, which is not possible because we are in 2026 now. And let me put 2026. This is the due date, and customer email, and I will confirm the order, and it's giving me all the calculations done. And this is how the program works. Okay, so this is the current workflow. Let's compare it to another workflow in which all the steps are executed in sequence. This is completely in sequence, and whereas in the current implementation, I'm making use of parallelism. It's not true parallelism, it's more like concurrency. So if you're calling an external API, or when we are calling databases, that's IO bound operations. IO means input and output. When we are reading a file, that's an IO bound operation. When we are calling a database, that's an IO bound operation, and we can parallelize that by using concurrency. And here in this implementation, I have used async. I have defined these DB query and BOM functions as async functions. So yeah, that enables parallelism. And I have used LangGraph framework here because it's a nice orchestration framework, and I can easily integrate LLMs later on if I want in the project, in this task. But then in this current implementation, I haven't made use of any LLMs because it will be an overkill for this simple task. And also LLMs API calls are costly, and there will be latency, and the output will be non-deterministic. And also I have made use of something called SQL Alchemy to call the databases. So the idea behind SQL Alchemy is, rather than writing SQL syntax to call the databases, you make use of Python objects to call the databases. And the advantage of this approach is that when we are, let's say, switching to another database, like in my current implementation, I'm using SQLite, but I want to switch to Postgres, then I do not have to make any code changes if I'm using SQL Alchemy. But if I'm using, if I'm like querying with SQL syntax and changing the database, so I may have to change the syntax as well. So that's one advantage of using SQL Alchemy. Okay, let's check out the main.py file here. This is a front end. So here there is no implementation of the backend. I haven't implemented any data validation in this file. That's like loose coupling. So I want all the implementation of the front end user interface. I haven't written any code for backend or for databases. So that's like loose coupling. So I want each file to have single responsibility. It follows the single responsibility principles. And yep, and you can look at this code. So I'm making use of LangGraph's interrupt function. What it does is, let's say the agent enters into a node, and if that node has an interrupt function, that means that the user has to give some prompt, and that once the user gives that prompt, then the execution resumes. With interrupt, the execution pauses, and once the interrupt function receives the prompt from the user, then it resumes. And this while loop goes on. This is how the workflow is implemented. And I have also made use of logging here, app.log. Where is it? App.log dot here. So it's for the debugging purposes and monitoring the application, analyzing the activities. And then I've also when I'm running the application, orders.db database file is created, in which whatever the user has entered is saved into the orders.db. And I've also made use of Git. So let me show you Git log. Here, it's version control system. Let's say I made some code changes. I'm not happy with those code changes, so I can easily revert using git revert. So it's very effective tool for version control. And then let's go over the remaining instructions in the README. So we can add the new material using this command and pass these flags, material, unit, costs. And we can also add new job type using HTTP post request. So like we are provided this fast API file, which is dockerized, and I added a function with HTTP post that allows us to post new job types using this curl command. We can put this curl command into the terminal, and a new job type will be created using the HTTP post. And we can also view the job types using this HTTP get method. The limitations of this work is like of this what I just showed you. There are certain limitations, like we cannot it's best to build dashboards, visualization dashboards, to monitor the user activity, to debug the application or analyze the user activities. There are tools out there like Langsmith and Langfuse that can be used in this project. And what I showed you, like that this application runs locally. It's not running anywhere else. It's not running on the internet. So we can deploy this application onto the internet using some cloud services like AWS, Heroku, GCP. And I haven't considered too much about the scalability. So like if there are many users interacting, millions of users interacting with the application, so we have to make some architectural decisions here, like databases, adding more servers. The software engineering in the end of the day is a team sport. So, and I have worked by myself on this project, on this task, but ideally I want someone else to review my codes as well. Like for example, I can make code changes, and then I can make a pull request for other person to review my code. So this is how we can collaborate in a team. And testing needs to be done, unit tests, integration tests, CI/CD pipelines should be configured, and application security concerns should be considered as well.